Good morning. Today we're going to be working on Algebra 2 Lesson 8.5 Rational Functions, and our focus is on horizontal asymptotes. We're also going to be looking at X-intercepts and other features related to those. And so if you remember, your rational function is some fraction. Just a simple example of that is if you have, say, 8 divided by, 13, that would be where you were going to take the 8 and you were going to divide that by 13, and you're going to get some number less than 1 here. We don't know what it is, but it's going to be some number less than 1. So you're dealing with that issue, and so our function looks like this. It's in the basic form of some numerator with x in it over some denominator with x in it, right? So you've got 3 possibilities for horizontal asymptotes in these kinds of functions. So if the degree of the numerator is less than the degree of the denominator, then we're going to conclude that the horizontal asymptote equals, well, it's y equals 0. Okay? And an example of this would be y equals 2x minus 1 over x squared plus 3. And of course, we assume there's a 1 here, and so you'll see the numerator is less than the denominator. And so in that case, you get a horizontal asymptote where y equals 0. Now, if the degree of the numerator equals the degree of the denominator, it looks like something like this. You've got a horizontal asymptote where, let's just say we've got 3x squared, y equals 3x squared divided by 5x squared, and that's going to simplify. You're going to divide out the x squared and the x squared, and you're going to get 3/5. So your answer here would be y equals 3/5. Okay. And again, the example might be in something like y equals 3x squared minus 7 divided by 5x squared plus 7. Okay, let's do minus 2 at the top here, minus 2 plus 7. And so that would be the kind of example you would have. Again, you've got 2 degrees that are the same, okay? And when that's the case, you use the 3 over 5, okay? So then the last one is where your numerator is greater than your denominator. And so in that case, if the degree of the numerator is greater than the degree of the denominator, then your horizontal asymptote doesn't exist. There's no horizontal asymptote. And instead, you got something called, creates what we call a slant asymptote. We are not going to study that now. Just something that you will know for, okay? All right, so let's move on. All right, so we have some examples. And so first of all, we want to find the horizontal asymptote. All right? For the function. And so you'll look at this example and you'll notice that it is in standard form. You've got a leading degree, x2, and then you go x to the 1. And then you've got x, so this is x to the 1, if you will. And this is x to the 0. And, pardon me. Did somebody have a question? Yes, Adam, you can redo part 1. So let me do this. Why don't you do part 2 now? I'm in the middle of recording, and I will come up with part 1 over the evening and have it for you in the morning, okay? You're welcome. All right. So, sorry about that. So this is in standard form. And notice there's no grouping symbols to deal with. No grouping symbols, which is good for what we're doing. So the only thing we're going to need are the leading terms. Makes it a lot easier to do this. So you'll notice I have 6x squared and I have 5x squared. Those are the leading terms. So we can say the degree of the numerator equals the degree of the denominator. Right? And so therefore the horizontal asymptote is going to equal y equals 6x squared over 5x squared. And then, of course, the x squareds cancel, and you're left with 6 over 5. So your answer is y equals 6 over 5. That's your horizontal asymptote. That's where it's located. Okay. All right. So the next one here, this is x to the 1, right? And this is 2x squared, right? And we don't want to forget the 2x. So in this case, 1 is in the numerator and 2 is in the denominator. So the numerator of x is going to be less than the denominator of x. And so our horizontal asymptote has to equal 0. It's going to be y equals 0. Okay? And why can't you do any division here? You can't do any division here because the denominator is the greater number. And it's what we had said previously about this. So just remember that. Can't do division because the denominator is the greater number. Okay? So that's why y equals 0 in that case. All right, let's look at this one here. We have, now this is factored form. So with this, we're going to have break this apart. We've got, let's see, we've got 3, we've got 2x, and we got a 2x over here. We only need to deal with the initial terms here to multiply them up into the leading term. So what we're going to go ahead and multiply these together. So we're going to find the lead terms. All right, so that means, let's see, we've got 3 times 2 x, right? Oops, can't draw an x to save my soul. 3 times 2x, and then times another 2x, right? And then in the denominator, we have 3 times 2x. All right, so this is going to equal 3 times 2 is 6, times 2 is 12, x squared. So I have 12x squared in the numerator, and in the denominator, I have 3 times 2, or 6x. And that's, of course, x to the 1. So the numerator is 2, the denominator's degree is 1, so the degree of the numerator of x is greater than the degree of the denominator of x. And so in that particular case, again, when it's greater, no horizontal asymptote. Okay? And it's going to, again, be a slant asymptote. Okay? All right, so then over here, we're going to do the same thing. We're going to multiply just the lead term. So we've got 2 times 3 times x times 3 times x. So 2, 3x, and 3x, right? Divided by, and then down here we have 3 times x, and we have x. So we've got 3 times x. So we can multiply the leading term together. 2 times 3, 6 times 3 is 18. Got 18, and then I have x times x is x squared divided by 3x squared. And so we can go ahead and divide out the x squared, and we'll notice we have, this is 6 if we divide both by 3 on the top and the bottom. So we're left with a horizontal asymptote of 6 over 1, or 6. Okay? And remember, that's because y equals 18 over, what did we say, 3, which equals 6 over 1, or 6. All right? So that's all we're doing to find that horizontal asymptote. Okay. Find the x-intercepts. That's the next thing we're going to do. So, what do we got to do first? Factor. So let's factor first. Because none of this has been factored, and we got to be able to go through and do that. So we've got f of x equals, and so I've got x squared minus 100. Remember that's difference of squares, so that's x plus 10 times x minus 10. And that's going to be divided by, all right, so let's factor the bottom. Let's see, what times what equals 2x squared? That's going to be 2x and x, so 2x and x. And then what times what equals 90? Well, we know we've got -9 and -10. Let's see, so 2 times -10 is -20, and 9 times x is -9 times x is -9. So yeah, that'll work. So -9 and -10, right? And if you look at that, oh yeah, we've got x minus 10 and x minus 10 here. We've got a hole. This is a hole. If you remember from the last time around, hole at x equals 10. And why? Because you would take x minus 10 equal to 0, and add 10 to both sides, you get x equals 10. All right. So now we have a reduced function. So we're going to do the reduced function. This is from yesterday again. And so that's going to equal, we're left in the numerator with x plus 10, and in the denominator we have 2x minus 9. And so we're going to find the zeros. So in the numerator you get the zeros for x, what x is. So the zeros, or x-intercepts. So if you take x plus 10, you make it equal to 0, x equals negative 10. So you're left with an x-intercept of negative 10, comma 0. Okay? And so we know then, let's just set the y to 0 if we want the y-intercept. 0 equals, and we'll use the reduced function, x plus 10 in the numerator and 2x minus 9 in the denominator. And then if we solve for x here, what we're going to have to do is multiply both sides by 2x minus 9. Now 2x minus times 0, if we distribute this, we're gonna end up with 0. Something. This is going to cancel out, so you're going to end up with let's see, 0 times negative 9 and 0 times 2x is just 0. So you end up with 0 equals x plus 10. Okay, so solve for that, and you subtract 10 on both sides, and you get x equals negative 10, which is again your x-intercept up here. So it's just showing you how that all works out. Okay, so now we're going to do b over here. So we want to factor this. So we're going to do f of x equals, now this factors into, let's see, what times what? Let's do two bubbles. X times x is x squared, and then what times what equals 18, that added together equals 9. 9 and 2 is 11, 6 and 3. So 6 times 3, okay, so plus 6 plus 3, because just go back and do the rainbow. 3x and 6x is 9x, okay? So that's divided by 3x plus 4. And these are going to be your x-intercepts, right? Right? This is going to be your vertical asymptote. Vertical asymptote. So your x-intercepts are going to be x plus 6 times x plus 3, and we're going to set that equal to 0, so you end up with x plus 6 equals 0, and x plus 3 equals 0, so you know your x-intercepts are x equals negative 6 and x equals negative 3. So you have two x-intercepts. And they're going to be at, because, and you're going to have to do it this way because Delta Math is going to want this, at negative 6 comma 0 and at negative 3 comma 0. Okay? So these are the way answers are done in Delta Math. delta math style, I'll say. And this over here, of course, is one x-intercept. Okay. All right, so let's move on to the next one. All right, so we have a couple of linear factors, one divided by the other, but let's see if we can do the x-intercept. So the x-intercept's coming from the numerator. X-intercept would be x minus 9 equals 0, right? So x has got to equal 9. So one x-intercept for this, and that's going to be at x is 9, comma, y is 0. Right? And that's your answer. Pretty easy. Okay, this one here, I've got a linear factor at the top, but I'm going to have to factor the bottom. So f of x, and this should be f of x equals. Drop that off. So f of x equals, and in the numerator it's x minus 3. Okay, in the denominator, and we'll put that in parentheses. Denominator, we've got a double bubble. I've got x and an x. For x and x is x squared. Then what times what equals 21? That when added together equals negative 10. It'll have to be two negative numbers. 3 times 7, negative 3, negative 7 is negative 10. So negative 3 times negative 7, right? So x times negative 7 and x, x minus 7, x minus 3, not times. And by golly, here's your whole. So these go out, you got yourself a whole. Right? Okay. So we've got a reduced fraction now. So our reduced function, if you will, f of x equals, well, this is, remember this is 1, right? So I've got 1 over x minus 7. So the question is, x-intercept, is this x-intercept? Well, let's find out. This should be the vertical asymptote, right? Because it's in the denominator. Let's try the x-intercept. X-intercept would be 1 equals 0. Well, does 1 equal 0? Yeah, it doesn't equal 0. So, there are no x-intercepts. No x-intercepts. Okay. Okay. So not too hard, not too hard. Let's move on. Okay, so now we're getting to the end of this, and this is where we sort of put it all together. So let's start out finding the horizontal asymptote. Okay. So again, that's the leading term, remember? And so what do we got for leading term with this problem? We've got x squared over x plus 1. These are the leading terms, 2 over 1. It looks like y equals x squared over x. And so the numerator of this thing, the numerator of x is greater than the denominator. Right? And so in that case, when the numerator is greater than the denominator, if you go back and you look at the start of all this and the rules, when the numerator is greater than the denominator, you get where is it? No, here it is. No horizontal asymptote. That's the slant situation. So you would just color in. This is a delta math answer, obviously. you would just color this in, no horizontal asymptote on this, okay? Let's factor this. So we've got this equals x, well, let's just figure this out. We've got x and x, and then we've got what times what equals 1 when added together equals 2. Well, that's x plus 1 times x plus 1. And that's over x plus 1. Looky there. So we got another whole. All right. So we have a whole at -1. So we go down and say that x, let's see, x equals -1. This is at x equals -1. So we put down here, we would write -1, and this is 0. Okay, that would be the whole. And then we're going to get a reduced function here. So reduced f of x equals, this is what? X plus 1 over 1. Right? So this has got to be our x-intercept, right? And this has got to be our vertical asymptote in the denominator. Okay? So, now when it says a vertical asymptote equals 1, well, you notice it's not x equals, so there's got to be no vertical asymptote, really. So we would put in here no vertical asymptote. Mark that in, okay? And don't have an answer for what x is, because there's no x there. All right, but what about x-intercept? Well, x-intercepts would be x plus 1, let's use this, x plus 1 equals 0. Okay, so that's what's in the numerator. And x equals -1 then. All right, and, oh, but we said the whole is at -1, and we got x equals -1 as the intercept. So which goes first? Well, the answer is the whole always goes first. The whole will take precedence. So we'll put that down, and so we're going to say, for the purposes of this, that we have no x-intercept, because it can't be, this answer can't be both an x-intercept and a whole. Okay, the whole rules, or the whole wins, if you will. Okay, so you got the whole down here, right? Okay, so what about y-intercept? So let's see, we have f of 0 reduced. We use the reduced function up here, so we're just going to call f of 0 equals 0 plus 1 over 1. What's that leave us with? Leaves us with 1. So that means then that where your x is 0, because your y-intercept, the x is always 0, the y is going to be 1. Now again, where did we get that? We took that from here. We took the reduced function and we brought it down here. Okay? And that's how we got that. All right. One more to go. Okay, so here, can we factor these? No, can't factor. So there's no holes. So no holes. Okay. No holes to take precedence. What about a horizontal asymptote? Well, we got leading degree here, 1 and 1, so those equal each other. So we have y equals, and this is going to be 2x over 4x. So 2x over 4x, and of course we cancel out the x's, and we're left with 2 over 4, which simplifies to 1/2. So our our horizontal asymptote equals 1/2 in this particular case. All right. Vertical asymptote, the denominator equals 0. So now how do we know that? Well, here's the denominator, 4x minus 9. That's going to equal 0. Add 9 to both sides. And you get 4x equals 9. Divide by 4. You get x equals 9/4. So what is that telling us? That's telling us that vertical asymptote, x is going to be 9 over 4. Okay. So I'm sorry, I think I misspoke. I said the denominator is 0, which is true. We set the denominator to 0. So set the denominator to 0. We took the denominator, we set it to 0, and we found out that the x would be 9/4. So the vertical asymptote is where x equals 9 over 4. Okay. All right. Now, for the x-intercept, okay, you're going to go ahead and, let's use a different color here. You're going to go ahead and set y equal to 0. So that means you've got 0 equals, I'm going to put it over here, 0 equals 2x plus 9. 2x plus 9 is in the numerator. So we're going to take the numerator for the y-intercept. I'm sorry, for the x-intercept. We want the numerator. So we got 0 equals 2x plus 9. And so negative 9 is going to equal 2x divided by 2, and you get negative 9/2. Okay, so this is negative 9 over 2. Okay, and so then for the y-intercept, of course, you set y equal to 0. I'm sorry, you set x equal to 0. So we will do, I'll use a different color again, f of 0, because that's, you're setting your x equal to 0, equals 2 times, now we do the whole thing, 2 times 0, the whole thing meaning the whole fraction, because we didn't have a whole to reduce. So 2 times 0 plus 9 over 4 times 0 minus 9. And then that simplifies to, this is 0 and 0, so 9 over negative 9, right, which equals negative 1. So that means my y-intercept is going to go in here at negative 1. Okay? hole, we said no holes. So we just put down no holes. We're good. All right, we are done. That is it. So it's kind of interesting work. It's gonna take some practice to get through this, but you'll get used to it, and you should be able to do this without any trouble after you keep working on the practicing. Okay? Take care. Bye-bye now.